The hammer button will compile your code and check for any errors. The bug button will compile your code and then load it on the board. If you just want to check for errors, don't spend the time it takes to load the program onto the board. Just build it. The resume or play button will run the program from wherever it is stopped. If you've just loaded it, it'll be the beginning. So I'm going to run this program, and you can see that the light is blinking on and off. Next to it is the suspend button, more commonly referred to as pause. This button will stop the execution of the program and tell you which line you stopped on. This is useful for checking if your program is getting stuck in an infinite loop. And the light has stopped. If you hit resume, it will keep running from where it was suspended rather than starting over. If you do want to start the program over, you can use the CPU restart button. Now when you hit resume, it starts at the beginning. You can also force Code Composer to stop on a specific line of your program by using a breakpoint. You trigger a breakpoint either by double-clicking on the margin by the line you want to stop on, or right-clicking on it and selecting Toggle Breakpoint. You remove them by the same process. It's important to know that the line it's stopped on has not been executed yet. The line always highlights the instruction that Code Composer is about to execute. Breakpoints are the best substitute for the cout statements you've used while debugging C++ code, because you can tell if a specific part of a program is being reached. You can change the placement of your breakpoints without reloading your code on the board. However, if you edit your code while in the debugging mode and it changes the line placement, your breakpoints will still align themselves to the old line placement. You must reload it on the board in order for the board to know that you have made changes. When the program has been suspended, either by pressing pause, hitting a breakpoint, or even if it hasn't started yet, you can step through the code one line at a time using the yellow stepping buttons. You shouldn't need to worry about the green ones. This is the best way to check if your algorithm is doing what you thought it would, and will help you find runtime errors. There are two stepping buttons, Step Over and Step Into. The difference between them is that Step Over will execute functions and subroutines and then move on. Step Into will jump into the subroutine and then go through every line of that. If you know a function is working as it should, use Step Over to skip it and save time. When you're debugging functions, use Step Into. Stepping will be especially useful to check your timing. Sometimes the board does an action so quickly that you can't see it happen, such as blinking an LED. But if you step through it, then it slows the action enough that you know it's being done. When you're stepping through your code, you can see the contents of all your registers to check for erroneous values. To make the window appear, go to View and select Registers. As you step through the code, you can see when the changes are made to the registers and what their contents are changed to. You can also see a list of errors by opening the Problem window under View. Clicking on the problems that appear will typically take you to the line where the problem is for minor syntax errors. Sometimes, though, the problem window will tell you there is an error and not tell you where it is. Most commonly, the following symbols are undefined, but it won't say which symbols. If this happens, open the Console window under View. Scroll up through the text in the console. There's another error list with different information which can often help you find the problem. Lastly, you can use the red stop symbol to exit the debugger mode.